Hello, thank you for tuning in. This is Revertible Recoverable Schema Migrations in Vitess. My name is Shlomi Noach. I work as an engineer at PlanetScale. I author a bunch of open source projects like Orchestrator, Ghost, and others, and I'm a maintainer for Vitess. PlanetScale was co-founded by the creators of Vitess, and we build on top of Vitess. We do have a private beta program, which I will only briefly mention later on. Today we're here to discuss about new developments in Vitess, a database clustering system for horizontal scaling of MySQL. Vitess is a CNCF project. PlanetScale doesn't own it per se. There are maintainers from multiple companies outside PlanetScale, but we are the main contributors. So what's on the agenda today? This session continues two previous sessions I gave at Percona Live 2020 and at FOSDEM. We're going to very briefly recap what's discussed there. We'll also very briefly again discuss the very basics of architecture of Vitess. We will then introduce VReplication, which is an integral flow or logic inside Vitess, and show how VReplication gives us new superpowers around online DDL. Specifically, we're going to elaborate about revertible, lossless schema changes and recoverable migrations. And as bonus content, we also have declarative schema changes. So very basics of Vitess architecture, and we'll only focus on the VT tablet part. So if you consider your normal MySQL replication topology, we attach a VT tablet, which is a daemon on each of the MySQL servers. It's typically running on the same server co-located with MySQL. It communicates with the MySQL server and can control the daemon. So like it can take a backup or it can run a query on the MySQL server. And it also maintains some private state by creating a schema called _vt and populating some tables within that schema, and that's going to be very useful to our discussion today. So in production you will have many clusters, and you will want to somehow route queries to these clusters. And we introduce VTGate, which is a smart Vitess component which acts like a proxy. It speaks the MySQL protocol. It knows how to route your queries to the appropriate cluster, to the appropriate shard. How does it know how to do that? Well, when the app connects to VTGate, it will use a specific schema. It will supply certain parameters, and based on that, we will route the query to the correct location. This meta information is contained in what we call global topo, which is like an etcd or a console or a zookeeper. That's like the stateful backend for Vitess, which contains all the information about the shards, the clusters, the sharding schemes, etc. And as recap, Vitess introduces Online DDL, which is a seamless, integrated way to run online schema migrations within Vitess without all the hassle of operating an actual, Ghost or PD Online schema change migration. So basically, you will set a DDL strategy to something, for example, Ghost, and then you will proceed to just run your normal alter table. Behind the scenes, when Vitess notices that you requested a Ghost DDL strategy, it will take care of all the necessary operation of, what are the appropriate shards? Am I free to run this migration right now? Creating an account for a MySQL user to run that migration. Run either Ghost or PD Online schema change. Configure the command line flags, throttle, automated throttling with Vitess, garbage collect the leftover tables, etc. So all this hustle is taken care of by Vitess. And today we want to talk about VReplication, a core component in Vitess, a distributed flow in Vitess, which allows us to move data from here to there, from one location to another. Some common use cases are live resharding. Vitess is able to live reshard your sharded environment while still routing the queries appropriately. or to create a materialized view, or to import your data from an external data source, or to move table from one cluster to another, again, live. In VReplication, in a VReplication workflow, there are streams. A stream imports data from one tablet, thus one MySQL server, and exports it onto another tablet, another MySQL server. And there could be multiple streams in a given workflow. Let's take an example, the move tables operation. In this notion, you have this huge monolith cluster, you have this huge table, it cannot be contained anymore, and you wish to move that table outside the monolith cluster onto its own dedicated, possibly sharded cluster. And so Vitess will take care of moving the data from the original cluster to the target cluster, but also later on shift traffic so that your traffic will automatically access the table on the new location. And the idea is going to sound familiar to people who are already a little bit familiar with Ghost or with PD-on schema change. To move data, you first have to copy, the existing bulk of rows on the source table, like 100 rows at a time, 1,000 rows at a time, and apply those on the target table. And in addition, you have to tail the binary logs on the source database and catch those events that apply to your table, and then apply those events appropriately on the target shards or on the target cluster where your the table is newly located. So this sounds very much similar to Ghost, and indeed it is very similar in essence. The implementation is a little bit different, as we'll see later on. And once the data is moved, we can allow the user to, for example, switch reads or switch writes, in which case Vitess takes note that the user wants to start shifting traffic to the new table. And so VDGate will automatically reroute traffic from the old cluster to the new cluster without the user having to update their application. Later on, once all traffic is switched, the user can later conveniently update their app and remove the entry, the routing entry from Vitess. And last but not least, VReplication supports a reverse notion, so that if something does go wrong, Vitess allows you to replicate back from the new location to the old location. So you can fail back in operation in case it doesn't work out. And we're going to introduce VReplication for Online DDL today. The idea is that VReplication's mechanism already sounds awfully familiar and awfully similar to Ghost. What it lacked was some automation around the process. So we introduce Online DDL through VReplication, where the source and target tablets are one and the same. Like Ghost and PD-on schema change, we create a shadow table, a Ghost table, and we replicate events from the original table to that Ghost table on the same server. So we do need to automate the creation of the target table. We do need to automate figuring out what the VReplication definition is, like what the query is, what kind of columns it needs to pull from the source table to the target table. We will need to automate the cutover. There's no user to tell us to switch reads or switch writes. We have to do that at the right time. And that creates an online DDL mechanism. And so we introduce online DDL through VReplication. It looks just like Ghost or PD-on schema change migration. You will set at DDL strategy equals online, and that ensures that your next migration runs through VReplication. Internally to Vitess, this is obviously more convenient to have a single logic to handle all data migrations. VReplication already takes care of move tables and exports and imports and materials views, it only makes sense to also run online DDL on top of VReplication. But on top of that, VReplication provides online DDL, or gives online DDL some new extra superpowers, two of which we're going to present shortly. So the first extra superpower is Revertible Online DDL. You run a schema migration, something goes wrong at the end of the migration. Oh no, we made a mistake. With VReplication, you're going to be able to run a lossless revert back to the original schema. Let's take a look at a demo. Let's look at the production use case and see what VReplication can do for us in a failure scenario. I'm going to create this table, sample data. I have this script that populates the table with data, and over here on the right, we're routinely showing what the schema looks like for that table and how many rows we have. That number is generally growing. So I do have a schema migration I need to run, and we're going to add a column, drop a column, modify some indexes. It's a big migration. It's going to take 5 hours in production, though of course in our demo it's just going to take a few seconds. I am using DDL strategy online, which means we're using VReplication, and that's important. So we're running this migration. I get this job ID. Check it out over here to the right. It's an online migration. The numbers are still growing. Migration is complete actually right now. The numbers are still growing, so we're good. And there's the new column and ID change from int to big int. So it looks like our migration is successful. Except it's 2 a.m. It took 5 hours for the migration to complete, and I just got paged. And I just got paged because I did modify the indexes a bit, and some query that was previously optimal now is not so optimal. And I did drop some column, and it just so happens that I missed a query or two that were still using that column. Now I'm not in complete outage. Data is still flowing here in. Check it out. The numbers are still growing. So data is coming in, but large parts of my website are not responsive, returning an error. So I'm in an outage situation. What do I do? So I have a few options. If I were to run this with PD on schema change or ghost, you know, there's the shadow table, and at the end of the migration we flip tables. I still have the old table. So if this were a PD on schema change or a ghost migration, I could try to rename back the old table into its original name. Now do keep in mind that between the moment I got paged to the moment I woke up, set at my computer, checked it out, figured out what was wrong, let's say 10 minutes have passed, we still have 10 minutes worth of data flowing in. If I'm going to rename the old table back into its place, I'm going to lose 10 minutes worth of data, which may be salvageable later on tomorrow or the day after, but this is going to be very surprising to my users. That's the 10 minutes worth of data are lost. What other options I have? I could reconstruct a new migration to get me from here into the original schema. Now we know it took us 5 hours to get here. It's going to take us 5 hours to go back. So I'm going to suffer 5 hours more of outage. My third option is to possibly hunt down the offensive queries and fix them on the fly as quick as I can. Let's agree between you and me that the time it would take me to find these queries and review them and deploy them to production, etc., is going to take like 30 minutes, best case scenario. So those are still 30 minutes where I have to suffer outage. Fortunately for us, we ran this migration with VReplication. And so we have a new superpower. We can revert Vitess migration. And let's use this job ID. So I'm asking Vitess to revert this VReplication migration and check out the numbers here, check out the schema. The numbers are still growing, and we are back at the old schema without losing data. I can't stress this enough. We've just reverted a 5-hour migration in a very short amount of time without losing data. So just how long did it take us to revert? Obviously on this demo, it just took, again, a couple seconds. So let's say we wasted 10 minutes worth of new data coming in. And we'll explain shortly how this really works behind the scenes, but essentially what VReplication needs to do is to reapply 10 minutes worth of binlog data, and not all of the 10 minutes worth of binlog data, just the binlog entries that apply to our specific tables. So let's agree that this is going to take a minute, maybe 2, maybe less than a minute, to catch up on the particular changes on the particular table out of the 10 minutes worth of binlog events. So we're super happy. This is like a superpower. I could use this in production multiple times in the past. But our story doesn't end, actually, because I woke up, I'm still pumped with energy, with adrenaline. I'm going to hunt down those offending queries anyway. And I do that, and it does take me half an hour to deploy everything to production. And now the code is fixed, and it's actually ready for that migration, which I wanted to run. And so at this point, I need to rerun my original migration. Only it took 5 hours to run that migration. I'm going to have to spend another 5 hours to run that same migration I already wasted 5 hours on, right? If only we had a mechanism with which we could revert something. So good news. The fact that we use VReplication means that we could revert our revert. So this revert was nothing more than a fancier form of an online schema migration, and as such, it is revertible. So revert Vitess migration. I'm going to revert that revert, which means I'm rolling forward my original change. Check it out. Check out the schema here, the numbers here, in a few seconds. And there we go. We are at the new schema again, and the numbers are good, and we did not lose any data. So now let's talk about how that works. How does that work? VReplication uses 2 underlying tables in the _VT schema. One is called VReplication, and the other is copy state. VReplication table contains is a general purpose state and definition for the vStream. It contains like the name of the workflow, the source table, the query that is used to copy data from the source to target, but also the current GDID position at the time or at the current progress. And what's interesting is that this table, this table are committed within the same transaction as the transaction that updates the target table with the binlog changes. The second table is the copy state, which is likewise the table that reflects the progress of the bulk copy of the existing rows from the source tables. And again, it is committed in the same transaction as the query that applies the row copy on the target table. So together, these 2 tables comprise the state of the VReplication stream. So when we run a VReplication migration, we copy the rows, the binlog events are good, replication is low, we're ready to cut over. We pause, we disable writes on the original table. We consume the remaining binlog event. We're satisfied that everything is in sync. We take note of the GDID position and we write that down in the VReplication table. And then we rename tables, we flip them. We actually flip them. We don't push the old one aside and the new one in its place. We replace the 2 in between themselves and we release the lock. So the VReplication table now has the GDID at the time of the cutover. When we want to revert a migration, we create a new flow. So it's a completely new migration that undoes the previous migration. And what we do is we cheat. We populate new entries in the VReplication table that presents a so-called request for a new migration. So we populate the row with information about the source table and the target table, and we reevaluate the query that would need to move data from here to there. And thus far, it's not very different from just submitting a new migration. Only we then populate the GDID position, the one we recorded earlier on. We don't populate anything in copy state because we've already copied the rows. We don't want the rows to be copied again. We just want to catch up with the bin log events. So now we tell VReplication, hey, take a look at that. And VReplication looks at that, and it seems to VReplication that there is a workflow where the row copy is already complete and is at GDID position this and that, and it's supposed to still run. So VReplication goes ahead and runs the flow and completes it. So it catches up on those few minutes from the moment we cut over to the current moment. It catches up on the bin logs in those moments, applies them, and when satisfied, goes through the same mechanism of cutting over. So that's how we revert a migration. Likewise, and unrelated to VReplication specifically, we also support revert for create table and drop table. When you revert a create table, we just hide the table away. You can revert the revert and make the table appear again. But more interesting is revert for drop table. If you drop a table, we can still resurrect your data. You drop a table, you revert the drop, and voila, the table reappears with all the row set that existed just at the time of dropping the table. So you can revert back and forth, create in and drops of tables as well. Next superpower, Recoverable Online DDL. You're running a migration. It takes a week, it takes 2 weeks. During that time, you just wish there's no failover. And any maintenance work you want to make on that cluster, you postpone because you really have to wait for the migration to complete. So how about running a recoverable migration? Remember that VReplication uses those two backend tables as the state for the migration. And those two tables get replicated just same as every other table in your database. However, your replication may lag at the time. Those tables on the replica are consistent with the progress of the migration as replicated on that replica. So if the primary goes down and you need to promote a replica, whether expectedly or unexpectedly, that replica will still contain those tables when promoted to primary, will contain those tables in a good state, and you'll be able to just resume the migration using that state to eventually complete the migration. So the idea is that you would not, as a DBA, you would not need to care about the migration running, you would not need to postpone anything. This is still work in progress and more testing to run. Next up, declarative schema changes. You will tell your database where you want to go, not how to get there. Let's check out a quick demo. In a declarative schema change, we tell Vitess or our database what we want our schema to look like rather than how to get into that state. We set DDL strategy to be equal online-declarative. We could actually do that with Ghost or PD on a schema change. This is not specific to VReplication. Let's create our sample data table again. The table is now created. There's some columns, ID int, unused column, etc. And we can see that everything is fine here and the table gets populated. What happens if I resubmit the exact same create table statement? Normally with MySQL, this query would fail because the table already exists. But in a declarative approach, we tell Vitess or our database, hey, this is the table I want. Make it so. And in our case, it's the exact same structure as the original table, so really nothing's going to happen. This is just going to be a no-op. And now, let's say I do want those new columns, new indexes, fancier table. Instead of running an alter, let's just give Vitess the new create table statement. This is what I want the table to look like. Make it so. So submitting this migration, and Vitess is going to compare this statement or this schema with the existing schema. And there we go. Vitess evaluated by itself the required alter statement and applied it, whether using ghost or opinion schema change or VReplication. And so for me, this is an approach that does not require me to understand about transitions or about did I formulate alter statements correctly, but even more importantly, this approach is idempotent. I can run as many of these create table statements one after another, and they're all safe because they will all converge on the state that I want the table to be in. How do we do that? We take a hybrid approach between the fully imperative method and the full declarative method. In a full imperative method, you tell your database alter table, drop table, create table. There's nothing to declare here. You tell your table, your database how to transition from one state to the other. In the full declarative approach, you just give your database your entire schema definition, your entire table set, and say, make it so. And this won't necessarily work well for some of Vitess's existing workloads and use cases. So we took a middle ground approach for now, where per table you will give Vitess a declarative-ish statement. It will either be a create table statement or a drop table statement, but never alter. So if you tell Vitess, drop this table, that means you want this table to not exist. And whether it exists or not, Vitess will make sure to just make it not exist. And that's easy. If you tell Vitess to create a table and the table does not exist, that's easy. Vitess creates the table. If it exists, Vitess compares the existing table with your desired state. If they are identical, nothing to do, we're all good. If they're different, Vitess evaluates the transition method from the existing state to your desired state, thereby creating an alter table statement and running it with either VReplication or Ghost or PD schema change. It works with all three of them. So this is not specific to VReplication. That's all we have for today. We have some resources online. Please join us in Slack. We have a good community. Browse the docs and, of course, browse the code, download, and try out Vitess. Thank you so much again for tuning in, and hope to see you in person in next conferences. Cheers.